So today we're going to take a look at this. The good old variac. They've been around for a long time, and the reason they're still being made today is because they're a useful device. Hey, what's happening, guys? Today we are going to play around and take a look at this guy here. This is a variac. A variable AC transformer. It can give you a lower voltage than your AC mains. It can actually even give you a little bit higher voltage than your AC mains, which we'll show you here in just a minute. But basically, all we've got here, I know you can't see in there. Let's unplug it first so we don't electrocute ourselves, and then we'll see if we can find the hole for the screw. That'd be useful. Take these screws out of the front here and give you a better look at what's inside. Now, before we get there, I will tell you simply, the AC comes in, goes through the fuse, to the switch, to the transformer, and out to the secondary. So, this is just a big transformer, auto-transformer, toroidal auto-transformer. Do not confuse this with an isolation transformer, because we're going to see this is not an isolation transformer. Doesn't mean we can't make it one, though. Man, they really torqued them in there. Now, these days, an isolation transformer isn't even an isolation transformer because, for safety reasons, they connect the grounds. From ones, they connect, this ground here to this ground here for safety reasons. Of course, if you know anything about electricity, you know that the ground in your fuse box is tied to the neutral wire. So you're not getting isolated. Man, one moment. Look at them threads. I don't know which some young guy was running the threading lathe that day in Shenzhen, but man, he really took a bite out of it. So, let us take a look at the inside portion. So here is where here is our AC coming in, and unfortunately it has the European blue and brown wires, but we do have the green. So here is our ground. Our ground is coming directly over here to this, so we have no isolation. We also have extremely shittiest soldering. But what I wanted to show you was the inside of this here. This is your toroidal transformer. If we get down in there, you can see that I just rotate this brush around and it taps the coil at different points. Man, I can't believe how bad some of that is. Look at that. Look at that. We got wires sticking up there. Wires. Oh, that's glue. I was about to seriously wonder about the high quality of this extremely low-cost Chinese product. You know what I'm saying? Look at the solder. Focus. There you go. That is not good. That is nicht gut, yeah? Oh, lordy, lordy. Oh, my goodness gracious. Yeah. We're going to have to tweak on that a little bit. Alright, well, I reflowed some of the more horrible connections. Now, let's talk about the ground again. So here's our ground coming in, going to that ground lug there, then over to here, where it is crimped to the case. So in theory, we could desolder this joint here, connect this wire to this wire, and we would have an isolation variac. However, I do not recommend you doing that. That could be very dangerous. For instance, if you were to have some sort of circuit malfunction and decided to lick the transformer, you could get a bad shock. So, don't do that. Alright, I'm going to put this back together and we're going to talk more about the variac. Okay, we're all reassembled. And my fingers now all feel somewhat slimy. All those wires had a slimy feel to them. Yeah. Alright, so brought out the meter here. Oh, hello. Sorry about that. Hope you didn't fall out of your chair. Alright, we're good there. So, what I want to show, we go here to here, and actually make contact with something in here. Am I not making contact with it? I see it flickering. There we go. Had to get right on the right spot. So you can see we have a direct connection there. We also have a direct connection with the case. So we're quite well grounded and quite safe. That, I mean, like I said, that's a good thing. Just don't confuse it with an isolation transformer. Alright, so now I plugged her in. And we'll put this on AC voltage. Now let me find a empty socket up here. And there you can see today's flavor is 126 volts of delicious, pure American 60 hertz sine wave goodness. So, let us probe this Dullyfinkel. So right now you see we're sitting at 2 volts. And as I turn the magic dial, which is indicating 13 volts there, you can see we're at 15 volts. We turn it up. There's 70 volts. I don't know if you can kind of see that meter there. We're still in the black. There's 96 volts and we're just inching into the green. There's a nice American voltage. And if we can zoom in here, you can see that's showing like 110 volts, where we are actually at 100 and just about 23. So as we continue to turn it past our mains voltage, we can take it up to 154 volts. But the main place you want to use these things is like down around 70 volts. Great for testing radios, transmitters, amplifiers, things like that. Why? Well, it all goes back to Ohm, good old George. And George said that voltage and current are linked together. In fact, he made an equation that says P equals I times V. So power is equal to current times voltage. If we limit one, we limit the other. And I will show you a demonstration of that here in just a second, and then we'll get into why this is useful. Okay, so what I've got here is an actual light bulb. Not an LED light bulb, but a filament type bulb. Plugged into our AC mains there. And you can see, maybe, it's drawing 0.639 amp or 639 milliamp. Now, there's nothing we can do about that. That is all it is going to draw from there. We can't change it because we have no control over the AC mains. However, if we plug it into our variac, which we can set for, you know, a random household voltage there. We close. Yeah. And then we turn our light on. Let's just turn up a little bit more so we're at 639 milliamps like we were before. Or close to it as we can get. So there is 642. Pretty close. But let's say we didn't know about this bulb and we wanted to test it. Well, you know, I can bring it down here to say 70 volts or so. And now we are only seeing 481 milliamps. And I can bring it even lower, and now we're only seeing 387 milliamps. We can even bring it to the point where it's just barely lit, and it's drawn just about 300 milliamps. But what's beautiful about this is, it's not messing with the frequency. This is fine for a purely resistive load. But if you have something else, you know, something that is requiring, you know, say a precise frequency or something along those lines, then, you know, using something that is going to change that frequency, like a, what do they call them, MFDs, those multi-frequency drives, it's changing the speed of the motor and such by changing the frequency. Here the frequency is going to remain the same, but we're going to change the power by dropping the voltage, and by dropping the voltage, we know we're also dropping the current. So let's take a look at what it looks like on the scope. Now I'm going to turn off these overhead studios here so you can actually get a better view of the scope. Now, a word of caution. Well, maybe more than one word. Many words of caution. You had better be damn sure you know how your household circuit is wired before you do this. Otherwise, not you can blow up your scope. You will blow up your scope. Okay? Here's what you have to keep in mind. This barrel jack right here is connected to ground. And what did we just talk about? Ground is connected to neutral. So, if you hook this up backwards, bad things are going to happen, because you are going to create a direct short between, get off of there, between live and neutral. So, let's bring in the meter once more. And we'll put it on AC voltage. Now, in the U.S., can I get this in here? Can I get everything in here? Sorry, Elvis. In the U.S., the smaller of the two plugs is the hot lead. And that means it is hot or live as opposed to the ground lead. Because in AC, of course, we're switching. So there's 32 volts. Let's crank this up to a nice household voltage, about 122 or so. Come on, baby, get in there. That's pretty good. And then if we come down here, we take a look at our little meter. You can see where, come on, get in there. It's just past the center green line. Alright. So, I know for a fact that my household is wired correctly. I know for a fact because I did it. So we will connect our ground lead here to Le Neutral. We'll connect our positive over there like that, making sure that nothing is touching where it shouldn't be touching. Then we'll stand back 3 or 4 feet, because even though I wired it, you know. Boom. There we go. So, 123.8 volts. And if we take a look on the scope there, you can see our sine wave. And we have our frequency there, 60.02 hertz, and there is our voltage. It's showing 125 volts. So what I'm going to do is I'm going to lower the voltage on the variac, and you can see our sine wave attenuating. So now we are showing 72.6 volts there and 73.4 there, but our frequency has not moved, and that's the key. We're adjusting the voltage and therefore the amperage. All together, we are adjusting the power, but our frequency remains the same. So if you're testing radio equipment or amplifiers, or if you want to be Eddie Van Halen and create the brown sound, one of these guys can be very useful on your bench. Like I said, just don't think it's an isolation transformer. It's not. Always know the status of your outlets. Whoops. What I'm looking for is my little diddly-wob tester here. There it is. This guy here. Now, will you focus on it? No. What if we go further away? Now will you focus? Really? Are you still not focused? I can't tell. My eyes are so bad. Focus. There we... Come on. Focus. Focus. Dude, why will you not focus on this? There. There we go. So we have the 3 lights at the bottom. And you can see how they would be placed there. What we're looking for is the 2 lights to come on. In this case, it would be these 2 amber colored lights right here. So we will plug this in. And you can see our 2 amber color lights are on, indicating we have a good ground, and our negative and hot lead are wired correctly. Alright? So that's a look at a super inexpensive variable AC auto transformer. I bought this off of Amazon, and I got it right before they went into shipping madness. Today is, what is today? March the 25th. I tried to order some things, and they told me they would not be here until April the 23rd. That is no bueno in my book, so I'm not ordering from them. What can you say? We live in strange times. Well, I hope you enjoyed this video. If you did, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. I appreciate all you guys watching. Wash your hands. Don't touch your face. That's it. I'm out. Peace.
I want to thank you all for watching and spending time with me today. A community like this is something that we can all be very proud of. So again, thank you very much for all your support of Learn Electronics. Please feel free to check out the Patreon page. $1 a month is all I ask, and really helps keep the channel alive. We also have an Amazon shop where you can buy most of the items that you see on here, and there's a link to it down below.